This is the third episode of my Rocketry series in which I present my homemade portable weather station. I started by designing a circuit diagram. In addition to the BME280 as a core sensor, I also wanted a battery monitor, a TFT display, and an RS485 interface. I will get to why I needed that later. As with my rocket launch controller, I used an Arduino Nano Every for this project. Okay, let's take a quick leap forward in time and get straight to the PCB. I usually solder everything by hand, including SMD components, but the BME280 is only 2.5 by 2.5 millimeters in size and the 8 pads are hidden under the sensor. I therefore chose a solder paste stencil for populating the BME280. I designed the parts for 3D printing in SketchUp again. To be honest, I hate that program, but I know it inside out and the web version is freeware. The parts were also printed again by my Chinese supplier. The material is called Resin 9600. It consists of photosensitive acrylates and epoxies and is the cheapest material you can choose for SLA. Brass inserts were glued in place because they cannot be melted into the resin. In addition, the supplier laser cut this blade from 3 mm aluminium sheet. To measure wind speed and direction, I opted for an ultrasonic anemometer that does not require any moving parts. It communicates via RS485 protocol. The sensor can measure wind speeds ranging from 0 to 40 meters per second and wind directions from 0 to 359 degrees with high accuracy. Wind affects the speed of ultrasound. Waves propagate faster with the wind and slower against it. Ultrasound can also be deflected by wind, so that the wind direction can be determined with a little trigonometry. Since I didn't really like the matte white of the resin, the parts were painted. Before doing so, I carefully degreased and cleaned them with isopropanol. I was really happy how the parts turned out. Next, I recut all the threads. Since the anemometer has to be facing north, a compass was needed. I used a diving compass, because it is better tilt compensated than one with a compass needle. The compass was glued into the designated fixture using 2-component epoxy resin. I utilized stainless steel standoffs so that the anemometer protrudes above the enclosure for the electronics. As with the launch controller, a 3S LiPo battery serves as a power source. The anemometer requires an operating voltage between 10 and 30 volts anyway. Incidentally, to avoid affecting the compass, all screws and nuts are made of non-magnetic stainless steel. In order to mount the weather station on a camera tripod, I purchased an adapter plate with a slightly longer 1/4 inch screw and a knurled nut. Finally, I took the weather station outside and put it through its first test. The code is pretty simple. Just read out the sensor data and display them on the TFT. To avoid retro flicker, I use the GFX canvas function. Before I say goodbye, I would like to thank my Patreons. Stay true, stay you.